Hello guys, and welcome back to our YouTube channel. In the last video, we were adding and subtracting matrices. So today we are going to be carrying out matrix multiplication, that is scalar multiplication and matrix multiplication. Okay, now let us start with scalar multiplication. Let's start with scalar multiplication. Scalar multiplication is simply multiplying a matrix by a scalar, that is by a particular number, a single number. So let's say we have the matrix A equal to 2 minus 1, 4, 3, and we have been given a scalar of 3. Okay, so to multiply this matrix by this scalar, we simply multiply the scalar by every element in the matrix. Okay, so we are going to have it as this. We are going to have 3 times 2, 3 times minus 1, 3 times 4, 3 times 3. Let me just cancel this. 3 times minus 1. So to multiply the number by the scalar, we are going to multiply the matrix by the scalar, we are going to multiply the scalar by every element. So this is basically 3a. So we are multiplying the scalar by every element in the matrix. So in this matrix, we will have 3 times 2, which is 6, 3 times minus 1 minus 3, 3 times 4, 12, and 3 times 3, 9. So this is what we are going to have for that matrix. So there are some properties with respect to scalar multiplication. There are some properties. K into A plus B is the same as K into A plus K into B. Remember, K is our scalar. So this is the first property. The second property, K plus M into A equal to K A plus M A. The third property, K into M A is equal to K M into A. The fourth property, 1 times the scalar is basically the scalar. 1 times a matrix is basically the matrix. The same as 1 times a number is that very number. It applies here too. So 5, 0 times the matrix is 0. 1 is a scalar, yes, it is a particular number. So 1 times any matrix is the same matrix. 0 times any matrix is 0, the same as 0 times a particular number. Let's say 3. 0 times 3 is 0, 0 times 5 is 0, 0 times 100 is 0. The same as 1 times 1 is 1, 1 times 4 is 4, 1 times even 100 is 100. That is the same thing which goes here. So let's take another example. Let's say we have a matrix C, which is 7 minus 6, 0, 2, 5 minus 1. And we have been given a scalar of half. So we are going to take C, half C. So here we are basically multiplying half by every element in the matrix C. So this will be 7 times half minus 6 times half, 0 times half, 2 times half, 5 times half, minus 1 times half. So that is what we get. And now we just simplify it. So this will be 7 on 2. This will be minus 3. This will be 0, 0. This will be 1. This will be 5 on 2. And this will be minus 1 on 2. So that is it. It's very simple, very short, and very straight to the point. Okay, so that is it for scalar multiplication. It is just multiplying a matrix by a particular number. You multiply every element in the matrix by the scalar which has been given to you. Now let us go to matrix multiplication. Matrix multiplication, this is multiplying a matrix by another matrix. Here, matrix multiplication, it is the most important operation because it's used almost in almost every part of matrices. So if you understand matrix multiplication, then can be rest assured that the other parts will not be as difficult. So in matrix multiplication, we have a rule. If A has the order m times n, if B has the order p times q, then the product AB will be possible if the number of columns in the matrix A is equal to the number of rows in the matrix B. Then the product AB can be possible. So here, this is m times n, and this is p times q. So I said that matrix multiplication is almost the same as addition and subtraction. In addition and subtraction, the order of the matrix has to be the same. Here, yes, you have to check for the order of the matrix first before you do the addition and the subtraction. You cannot, not every case can add and not every case can subtract. The same as multiplication, not every case can multiply. So we need to look for the order of the matrix. And as I earlier said, the product is possible if the number of columns in the matrix A is equal to the number of rows in the matrix B. So this AB will be possible if n is equal to p. Then we can multiply. And to multiply, the order of the matrix AB now will be m times q. Will be the number of rows in the first column the number of rows in the first matrix times the number of columns in the second matrix. That will be the final order of the matrix AB. So remember, for AB, the product AB to be possible, the number of columns in the matrix A has to be equal to the number of rows in the matrix B. So that is why here I said n must be equal to p for the matrix to be multiplied. Okay, so let us take an example. Let A be the matrix 1, 2, and 3, 4, 5, 6, and B be the matrix 3 minus 4, 1, 0 minus 3, and 5. Okay, so as I said, to look for the product AB, we need to determine the order of these two matrices and see whether it can be multiplied. So let's take the order of the first A. What is the order of the matrix A? It is a 2 by 3 matrix, and B is a 3 by 2 matrix. Okay, remember I said the product AB is possible if the number of columns in the first matrix is equal to the number of rows in the second matrix. So what do we see here? A is a 2 by 3 matrix, B is a 3 by 2 matrix. So the number of columns in the first matrix A is the same as the number of rows in the second matrix. So this matrix can be multiplied. And finally, the order of our final matrix AB is going to be this and this. So it's going to be a 2 by 2 matrix. So when multiplying, take note that your final matrix should be a 2 by 2 matrix. Okay, so now to multiply. The product is obtained, the product AB is obtained by the first row in the first matrix multiplied by the first column in the second matrix. So the first row in the first matrix multiplied by the first column in the second matrix. So here we are multiplying row by column, row by column. So if you add this, it's going to give us the element in the first row, first column of AB. Okay, so the first row of A is multiplied by the first column of B. So since this will give us a 2 by 2 matrix, this will be just A, B, C, and D. So we first of all multiply the first row of A by the first column of B. That will give us A. Because we are multiplying and adding, so we take this times this plus this times this plus this times this. Okay, now to get the second number B, to get this B, we take the first row again and multiply it by the second column of B. So we take this times this. That is what we take. Okay, if we take that, it will give us B. So let's go now to C. How do we get C? We have exhausted the first row. So it is the same as, let's say, 2 times 3. Let's say 2 plus 3, sorry, times 2 plus 3. So here we take 2, multiply it by this and this first before we take this and multiply it by this 2. So we take this times this plus this times this, and then we take this times this plus this times that. So it is the same principle. So it is the same thing here. So to get C, we take this times this. The second row of the first matrix times the first column of the second matrix. Then we take this again, the second row of the first matrix times the second column of the second matrix. So it is the same pattern. So we take this times this to give us C, and then to have D, we take this times this to give us D. So that is what we are going to be having. Okay, so let me show you how they do it. Okay, so now we take the first row times the first column. Remember here we are taking row by column. We multiply row by column. It is not addition or subtraction. In addition and subtraction, we are taking corresponding entries, but in multiplication, we do not take corresponding entries. We multiply rows and columns. So we take the first row times the first column. We are taking each element. So we take the first case, 1 times 3. 1 times 3 plus, we are adding them, 2 times minus 4. So the first element of the first row, 1, which is corresponding correspondent 3. The second with its correspondent -4. The third with its correspondent 1. So we have 1 times 3 plus 2 times -4 plus 3 times 1. All this will just give you the first element. Remember, it is a 2 by 2 matrix. That will just give you the first element. To get the second element, take the first row times the second column. So we have again 1 times 0 plus 2 times -3 plus 3 times 5. So that is the second case. Okay, the third case, this element here, we take this times this. So we have 4 times 3 plus 5 times -4 plus 6 times 1, and that is it for this element. Now this last element, we take the last, this times this. So we have 4 times 0 plus 5 times -3 plus 6 times 5. That is all. Now it is left for us to simplify it. Okay, so that is the idea. So here, adding the result gives us the elements. So if we multiply the first row in the first matrix by the first column in the second matrix, it will give us the first element. When you add, it will give us the first element. Then if we take the first row multiplied by the second column, the first row multiplied by the second column, it will give us the second element, this second element here. That is when you add it all. Now if we take the second row of the first matrix multiplied by the first column of the second matrix, it will give us this. When you add it all, it will give us a value. Now if we take the second row of the first matrix multiplied by the second column of the second matrix, it will give us this last value. When you add it all, it will give us a value. So now let us simplify it. So we have 1 times 3, which is 3, plus 2 times -4, that is -8. So we just write -8, plus 3 times 1, which is 3. Now let's go to this case. 1 times 0 is 0, plus 2 times -3, that is -6. So we just write -6, plus 3 times 5, which is 15. Now we'll go to this case. 4 times 3 is 12, plus 5 times -4, that is just -20, and then plus 6 times 1, which is 6, plus 6. Now we go here. 4 times 0 is 0, 5 times -3 is -15, so we just write it. And then 6 times 5 is 30. So that is what we have. Now we simplify it further. 3 minus 8 is -5. So here we have -5 plus 3. Here we just have -6 plus 15. Here 12 minus 20 is -8 plus 6. And there we have -15 plus 30. So we simplify it further. I'm taking this step by step for better understanding. So if you can do all the simplifications at once, it is better for you. So here we have minus 5 plus 3, which is minus 2. Minus 6 plus 15 is 9. Minus 8 plus 2 is minus 2. And minus 15 plus 30 is 15. So this is AB. So remember, as I said, our product must be of an order of 2 by 2. So this is a 2 by 2 matrix. That means our multiplication was on the right track. Now there are some properties of matrix multiplication that we should know. There are some basic properties. Matrix multiplication is not commutative. This means the product AB is never equal to the product BA. I will show you an example below to. So that is the first property. The second property, matrix multiplication is associative. That is, if we have the product AB times another matrix C, it is going to be the same as A times the product BC. So that will be the same. The third matrix multiplication is distributive. That is A into B plus C is equal to AB plus AC. And the fourth is identity. That is, a matrix A times its identity is the same as the identity times the matrix, which is the same as the matrix alone. So I earlier said let us have this. So let's take this matrix we had above. This was our AB. Now let's see whether it is equal to BA or not. Okay. Now BA, let's take the order. The order of B was a 3 by 3 matrix, a 3 by 2, sorry, and the order of A is a 2 by 3 matrix. Okay, this simply means that the matrix can be multiplied. Remember, if the column of the first matrix is equal to the rows of the second matrix, then the matrix can be multiplied. And finally, our BA, the product must be a 3 by 3 matrix. We can already see that they are not the same. Our AB had to be a 2 by 2 matrix, but they are already telling us that BA must be a 3 by 3 matrix. This already proves that AB is not equal to BA. Okay, so that is all for matrix multiplication. Remember, you check the order of the matrix before you start multiplication to determine whether the matrices can be multiplied or not. Remember, if the number of columns of the first matrix is equal to the number of rows of the second matrix, then the matrix can be multiplied, and so on. So let us remember this. And scalar multiplication, when given a scalar, the scalar multiplication of that matrix is simply the scalar times every element in the matrix. So that is all for today, guys. Thanks for watching this video, and I'll see you guys in the next video.